Good morning, all. Myself, Ramya, Assistant Professor, working in Department of ECE, Hindustan College of Engineering and Technology, Coimbatore. In this lecture, I am going to discuss about amplitude modulation system, which comes under the subject of analog communication. So now, what is communication? This communication word has been derived from the Latin word communicare, which is the meaning behind it is to share or to make common. So simply to connect the source and destination. So the signal, the person who is talking, that will be transferred as a signal, and the voice signal is being converted to electronic signal by means of a transducer, and by means of processor it has been given to the transmitter, and it is transferred to the receiver, and receiver again by means of transducer converts it to the signal which can be here audible by the receiver. So from one end, from mobile phone, is talking, that will be processed and transmitted through the antenna, and it will be received by the receiver at the other end, and the other person who is holding the mobile phone can receive that voice. So regarding the elements of communication, the sender will be there. Sender will be transmitting the communication, that is transmitting voice or message here. The medium is air, and receiver is receiver's mobile phone, and the message is nothing but the information which is conveyed. So communication plays the major role everywhere. So for communicating, the low frequency signals cannot be transmitted to long distance. So to reach long distance, I need to perform modulation. So first we will see what is the need for modulation, and we will proceed on. First is regarding frequency translation and increase in range of communication. The problem we face is the voice and video bit streams from the computer are of low frequency band. They can travel only the few distance but cannot propagate for long distance if it is through space. And the antenna size which we are using has to be very the height of the antenna has to be very long, such that it can transmit low frequency signals. So the antenna size, high antenna size is impractical, and so that we have to go for converting this low frequency into a high frequency, such that the antenna size can be a medium value, and also the noise can be minimized. So for transmitting over long distance, antenna size has to be nominal. For that, we have to convert the low frequency voice signal into a high frequency signal. So the reduction in height of the antenna is our next requirement. The size of the antenna is required as quarter the wavelength of the signal which you are transmitting. C is equal to F lambda. So lambda is given by C by F. If you use 2 kHz signal, the size of the antenna has to be 30 km. But if you increase the frequency of the signal to 2 MHz, the size of the antenna which is required is just 30 meters. So to consider the height of the antenna, we can increase the frequency of the signal. So the frequency of the signal is increased to 2 MHz, so that length of the antenna can be effective. And one more thing is, various persons are talking together. If various persons talk together simultaneously, what will happen is that they all will collide with each other, and the information will not be received by the receiver effectively. So that we are transforming each and every voice signal into a different frequency, such that those voice signals will not get mixed up, and the receiver can receive it effectively. So by means of modulation, the mixing of signal can be avoided, and bandwidth can be expanded, and the quality of reception also expanded. That is, the quality of reception is improved, because noise affecting the signal is minimized because of high frequency. When the frequency is high, obviously we are providing immunity. So now modulation. Modulation is nothing but the process by which some of the characteristics of the high frequency signal, which is called as carrier, is varied in accordance with the instantaneous amplitude of the message signal, which is modulating signal, keeping the other two parameters constant. Okay, so the modulating signals, any parameter can be varied. The carrier signals, any parameters can be varied. So modulation is defined as the process of changing the amplitude, frequency or phase of the carrier in accordance with the instantaneous value of the message signal. So simply like when you want to travel to long distance, if you go by walk, you cannot reach that long distance. So to reach that long distance, either you have to use bus or train or flight depending upon the distance. So the frequency is varied. So the carrier, the bus or train or flight which is carrying you to the long distance destination is nothing but carrier. In that carrier, the message signal is embedded. Demodulation is a reverse process to get the message signal. So the signals involved in modulation process is modulating signal, which is message signal, which is a low frequency signal. It is also called as baseband signal. And carrier signal is a high frequency signal which contains no information, which is just used to carry the message signal from one end to another end. And modulator is nothing but the process after the embedding of message signal onto the carrier signal. So here we are going to deal with analog modulation. Analog modulation refers to the message signal to be analog and carrier also to be analog. So depending upon the characteristic change which is done in the carrier, it can be amplitude, frequency or phase. If you vary the amplitude of carrier according to the instantaneous value of message signal, it is amplitude modulation. If you vary the frequency of the carrier in accordance with the instantaneous value of the message signal, it is frequency modulation. If you vary the phase of the carrier in accordance with the instantaneous value of the message signal, it is called as phase modulation. So we will start with the amplitude modulation, where the amplitude of the high frequency carrier is varied in accordance with the instantaneous value of the modulating signal, keeping the other two parameters, frequency and phase of the message signal, to be constant. So the baseband signal is taken and that is given to the modulator. Modulator tries to provide the amplitude modulated wave where the carrier's amplitude is varied according to the message signal, and that is transmitted at the demodulator. Again the reverse process happens and the message signal is retrieved with the same frequency FM. So this is the message signal. This is the message signal and this is the carrier. So this carrier signal's amplitude is varied according to this message signal. See, the amplitude has to vary according to this signal, message signal, right? So it will be in the top and as well as the bottom. Frequency should not change, only amplitude has to change. This is the amplitude modulated wave and this is the maximum amplitude of AM wave and this is the minimum amplitude of AM wave. This is Emax, this is Emin. So Emax is given by EC plus EM and minimum is given by EC minus EM. So we will see about the equation for amplitude modulated wave. Modulating signal is given by EM is equal to small em, since this is instantaneous value. Maximum amplitude EM sin omega mt. Omega m is the angular frequency of the message signal, which is given by 2 pi fm. And carrier is given by EC, small ec equal to capital EC sin omega ct, instantaneous value, maximum amplitude, angular frequency. Amplitude modulated signal, we know that E mod is given by the carrier's amplitude alone is modified, whereas frequency is maintained as such for the modulated signal. So E mod is equal to capital E mod sin omega ct. Capital E mod is given by the carrier's amplitude will be as such. With that, message signal's instantaneous value will be added. Message signal's instantaneous value given by Em sin omega mt. So substitute that value here. EC, capital EC plus EM sin omega mt into sin omega ct. So what will happen is that EC sin omega ct plus EM sin omega ct sin omega mt. We know that sin A sin B is equal to 1 by 2 cos A minus B minus cos A plus B. So applied here, EC sin omega ct plus EM by 2 cos omega C minus omega M into T minus cos omega C plus omega M into T. So this determines the expression for amplitude modulated wave with three components. One is carrier component, another one is one sideband component and another sideband component here, which is Fc minus Fm. So it is lower sideband component, which is lower than Fc. So it is lower sideband, and this is higher than Fc. So it is called as upper sideband component. These lower sideband and upper sideband are having the amplitude of Em by 2. You can represent it in another form like this. So if you take EC outside, you will get EM by EC into sin omega mt. This EM by EC is called as modulation index. Modulation index is defined as the ratio of EM by EC. So sideband is nothing but the band of frequencies which are lower and higher frequencies of the carrier frequency. So this is carrier, this is lower sideband Fc minus Fm, this is upper sideband Fc plus Fm. So the bandwidth required for transmission of this AM wave is upper sideband minus lower sideband, which gives you 2 Fm. So this component, this AM wave is called as double sideband full carrier. So double sideband full carrier's bandwidth is 2 FM, and the advantages of AM wave is it can be relatively inexpensive and travel over long distance, but it is not better when the noise is more and bandwidth will be wasted for a double sideband full carrier. So the AM is a low quality form of modulation for commercial broadcasting, and it is used in two-way mobile radio communication system and also in aircraft communication system. These are the references referred. And so as a whole in this lecture we have seen about double sideband full carrier amplitude modulation system. Thank you all.